Here's a riddle that breaks most AI models. A farmer has 17 sheep. All but 9 run away. How many are left? Ask GPT directly, and it often says 8. Ask it to think step by step. It nails it. 9. That single phrase, think step by step, isn't just a trick, it's exploiting something fundamental about how large language models process information. And once you understand why it works, you'll never write a complex prompt the same way again. Let's reverse engineer the most powerful prompting technique in your toolkit. Let's start with a concrete example. I'm going to show you the same math problem sent to the same model twice. Once with a standard prompt, once with chain of thought. The accuracy difference isn't subtle. It's not 5 or 10%. On multi-step reasoning tasks, chain of thought can double or triple accuracy. This isn't cherry-picked. It's been replicated across dozens of benchmarks. The question is, why does asking an AI to show its work change the answer it produces? To understand why chain of thought works, you need to understand why LLMs fail at reasoning in the first place. These models are next token predictors. They're trained to predict what word comes next based on patterns in training data. They're not running calculations, they're pattern matching. When a problem requires multiple logical steps, the model has to somehow encode all that intermediate reasoning into a single forward pass. That's like asking you to multiply 347 times 892 in your head without writing anything down. Possible, but error-prone. Chain of thought prompting was formally introduced by Google researchers in January 2022. The paper, titled Chain of Thought Prompting Elicits Reasoning in Large Language Models, tested a simple idea. What if we showed the model examples that include step-by-step reasoning, not just question-answer pairs? The results were dramatic. On the GSM-8K benchmark, grade school math problems, accuracy jumped from 18% to 57% on a 540 billion parameter model. That's the same model, same weights, same architecture. The only difference was the prompt format. Let me show you the structural difference between a standard few-shot prompt and a chain of thought prompt. In standard prompting, you give examples with inputs and outputs. The model learns the format and applies it. In chain of thought prompting, your examples include the reasoning process between input and output. The model doesn't just learn what answer to give. It learns that it should externalize its reasoning steps before concluding. This is the key insight. You're not teaching the model new knowledge. You're teaching it a new behavior. To think out loud. Here's where it gets interesting. A few months after the original paper, researchers discovered something surprising. You don't always need examples. Simply appending the phrase, "Let's think step by step," to a question with no examples at all triggers chain of thought reasoning. This is called zero-shot chain of thought. It's absurdly simple and it works remarkably well. The magic phrase acts as an instruction that changes the model's generation pattern. Instead of jumping to an answer, it generates intermediate reasoning tokens first. Why does "let's think step by step" work? It's not actually magic. It's prompt engineering exploiting training data patterns. These models were trained on internet text, which includes countless examples of tutorials, math solutions, and explanations that use phrases like step by step, first, then, therefore. When you include that trigger phrase, you're essentially telling the model, generate text that looks like the explanatory content you saw in training. The model shifts from answer mode to explanation mode, and explanation mode happens to produce better answers. Zero-shot is convenient, but few-shot chain of thought is more powerful for complex domains. When you provide examples with reasoning chains, you're doing two things: showing the model the type of reasoning you expect, and demonstrating your domain-specific logic patterns. Here's a template for few-shot CoT. Notice how each example walks through the reasoning explicitly. The model learns not just the answer format, but the thinking format. For domain-specific tasks, legal analysis, medical reasoning, code debugging, few short CoT with curated examples dramatically outperforms zero shot. Chain of thought isn't just for math. It's incredibly effective for code generation. When you ask an LLM to write complex code directly, it often produces something that looks plausible but has subtle bugs. When you ask it to first reason about the approach, what data structures to use, what edge cases exist, what the algorithm should be, the resulting code is significantly more correct. Watch how I structure a code generation prompt with explicit reasoning steps. The model thinks through the problem before writing a single line of code. Let's see this in action. I asked GPT-4 to solve the longest substring problem twice. Once directly, once with chain of thought. The direct approach produced working code, but missed an optimization and had a subtle bug with empty strings. The CoT version explicitly reasoned about the sliding window approach, noted the empty string edge case before coding, and produced cleaner, more efficient code. The thinking time translated into better output. This pattern holds across code generation tasks. Complexity handled through reasoning, not guesswork. Here's an advanced technique: self-consistency. Instead of generating one chain of thought, you generate multiple independent reasoning chains and take the majority answer. Think of it like asking 5 different experts to solve a problem separately, then going with the consensus. This works because different reasoning paths might make different errors, but the correct answer tends to appear more frequently. Self-consistency with chain of thought outperforms single path CoT on most benchmarks, especially for problems with multiple valid solution approaches. Taking this further, we get tree of thoughts. Instead of linear chains, you explore a tree of possible reasoning steps. At each step, the model generates multiple possible next steps, evaluates which are most promising, and explores those branches. It's like how a chess engine considers multiple moves ahead before committing. Tree of thoughts is more computationally expensive, but excels at problems requiring exploration and backtracking, puzzles, planning tasks, creative problem solving. It turns the LLM into a deliberate reasoner rather than a one-shot guesser. Chain of thought isn't magic, and it has failure modes you need to recognize. First, unfaithful reasoning. The model sometimes generates plausible sounding steps that don't actually reflect its internal computation. It might write, therefore, X when X doesn't logically follow. Second, overthinking simple problems. For trivial questions, CoT adds tokens without adding accuracy and can actually introduce errors. Third, confident wrong paths. The model commits to a reasoning direction early and follows it confidently to a wrong conclusion. Knowing these failure modes helps you know when to use CoT and when to use other techniques. Let me give you a library of CoT prompt templates you can copy and adapt. For math and logic, solve step by step, showing all calculations. For analysis tasks, break this into components, analyze each, then synthesize. For decision making, list the options, evaluate pros and cons of each, then recommend. For debugging, state the expected behavior, identify the actual behavior, hypothesize causes, test each hypothesis. These templates encode the reasoning structure you want the model to follow. Start with these, then customize for your specific domain. One practical challenge: you want the reasoning for accuracy, but you only need the final answer for your application. Here's the pattern I use. First, ask for reasoning in one call. Then, either pass the final answer from the response or make a second call asking the model to extract just the answer from its own reasoning. Some models support structured output or function calling. Use that to get clean JSON with both the reasoning chain and the final answer as separate fields. This gives you the accuracy benefits of CoT with the clean output your code needs. In production, chain of thought has cost and latency implications. More tokens means more money and slower responses. Here's how I balance this. For simple queries, skip CoT entirely. Use classification to route requests. For complex queries, use CoT but cache reasoning chains for similar problems. Consider async processing for non-real-time tasks where you can afford longer CoT and always log the reasoning chains. They're invaluable for debugging when the model produces wrong answers. The reasoning isn't just for accuracy, it's for observability into what your AI is actually doing. One important nuance: chain of thought effectiveness scales with model size. On smaller models, under 10 billion parameters, CoT often doesn't help and can even hurt performance. The model doesn't have enough capacity to generate coherent reasoning chains. The magic really kicks in with larger models, 100 billion parameters and above. This is why CoT works so well with GPT-4, Claude, and Gemini, but might disappoint you with smaller open source models. If you are using a smaller model, few shot with very carefully crafted examples can help, but don't expect the same gains. Here's your practice exercise. Take this problem and craft 3 different prompts. One direct, one zero-shot CoT, one few-shot CoT with 2 examples you create. Run all 3 against GPT-4 or Claude. Compare the answers. Note which got it right and examine the reasoning chains for the ones that failed. The problem? A company's revenue grew 20% in year 1, then declined 20% in year 2. What's the net change from the starting revenue? This is a classic trick question that trips up direct prompting. Post your results in the comments. I'd love to see your prompt designs. Let's recap the 3 things you learned today. First, chain of thought. Prompting works by giving the model scratch paper. Externalizing reasoning as tokens dramatically improves accuracy on complex tasks. Second, you can trigger CoT with zero-shot magic phrases like "let's think step by step," or use few-shot examples with explicit reasoning chains for more control. Third, advanced techniques like self-consistency and tree of thoughts push accuracy even higher by exploring multiple reasoning paths. Next up in the AI track, we'll cover react prompting, where the model doesn't just think, it takes actions and observes results. It's chain of thought combined with tool use. Subscribe so you don't miss it and drop a comment. What's the hardest reasoning task you've tried to prompt an AI to solve? I read every comment. See you in the next one.